What's up, people, and welcome to my tutorial in Introductory to Blockchains. So in this tutorial, what we're going to be doing is we're going to have a look at the basic mechanisms of how blockchains work. And we're also going to have a look at the different kind of components that it's composed of. And in order to illustrate this, I made this pretty simple Node.js application that we're going to be using throughout the series. And we're going to go through the code later on, but before we start doing that, we're going to have a little bit of introductory here to get you started and knowing what this is all about. So I'll just dive straight into that. So before we start, maybe we should have a quick notion of what a blockchain actually is and what it's used for. And I think today the most famous example of an implementation of a blockchain is probably in Bitcoins. And so we're going to follow along with kind of like that example, but a little bit simplified here. And what it's used for is basically creating a chain of blocks, hence the name, that is unbreakable basically. So you would have a couple of blocks that is pointing like this to each other. And one of the thing with blockchain is that you can tell if someone has been messing around with these blocks. So for example, if someone is trying to change the block here in the middle, you will know that from the next block and even like from any other block after that, because the checksums that is used will not be correct basically. And that is the abstract way of telling what blockchains are used for. So it's basically for verifying that everything is in the same order and no one has been messing around with the blocks in the chain. And that is a simple way of telling it basically. And in order to do this, we're going to look at what a hash is and what a block is, and also what kind of stuff we put in this block in order to be able to build this kind of structure. So if you already know what this is all about, you can skip to the next tutorial, but I suggest you stick around just so if you have missed something maybe. So let's start with the hash. And I don't know if you already know what this is, but a hash function is basically, it takes an input and then it gives an output. And when you give it an input, like ABC for example in this case, it'll output some random high entropy string. In this case I'm using a SHA-256, which we are going to be using in the examples also. But all hash functions does the same thing. They just do it differently and output different length, of course. But in this example, as you can see, I take an input and then I hash it and then I get this output right here. And one of the parameters or the mechanisms of a hash is basically that if you give it the same input twice, it'll always give you the exact same output. And this is used in other implementations of course, like when you save hashed passwords in a database, so you don't have to store it in plain text, for example. But that's a different topic. So here we're going to be using it in the blockchains. So you can see here, if I take ABC, I get this hash, right? And if I try and open up a new tab right here, now so you see that I'm mess around with it. So I get this output here. And if I type the same stuff here, these should be exactly identical and the same. So I take the first one right here, I copy that in here, take the second one here, and then I also copy it in here. So you can see they're identical, right? The thing is, there's also no traceability in this. So for example, if I just add one more letter, it gives me something totally different. So you can see there's no way of telling between these two that the input was only differentiating with one character, for example. They're totally different and there's no way of telling that basically. Another mechanism that is also in the hash function is that if you have the hash, you cannot reverse it. You cannot get back to ABC, for example, in this case, or with the other one here. I cannot get back to ABC1 like this. That is not possible. And that is also a very important aspect of a hash function. I think that's all you have to know about hash functions for now. The intricate details of how these are implemented are pretty heavy, I should say, but you can definitely dive into that if you like. So that was hashing, and in my example, I'm gonna use an example of a banking system. And the way banking system and bookkeeping works is basically that you have a lot of entries in your book like this that defines all the transactions that have been performed. So in the first transaction here, for example, I might take an account, like for example the bank account, and I might also have another account, for example savings. And if I want to transfer money from my banking account to my savings account, for example, let's say that I want to transfer 100 of any currency. The way I would write this is that I would keep the amount in a field, in this case 100, and then I would have one account that is credited, and in this case it's the bank. So I would do like this: credit the bank, and this is where the credit is basically where the money is coming from, and then I would use debit, and then I would use where the money is supposed to be transferred to, in this case my savings account. So this will create a transaction that looks like this. So I'll take 100 of something from the bank and put it into my savings account. And if I create transactions like this, the order definitely matters, and also, for example, that you don't leave out any transactions. And for example, if you create the same transaction multiple times, there is no way of telling this. So it's very important in this case that the chain of these transactions is exactly the same everywhere, because if you miss one of these out, now my account will be down 100 because one transaction is missing. So if I put it back in, the transaction is correct. That also means that if you have multiple accounts, and if you have multiple clients, sorry. So this is, let's say that this is client 1. If one of the other guys, let's say this is client 2. Let's say that this guy is trying to mess around with the accounts like this. Maybe he changes the amount, or saying that the debit shouldn't be here, but it should be to my other bank account, for example. Now the money will be transferred to this account instead. And that means also that if this guy here starts creating new transactions, they won't be correct, basically. So we in this case we need some way of telling that someone hasn't been messing around here in the middle. And that is what we're gonna have a closer look at in the coming tutorials. So in this case, what we're going to be having in this blockchain right here, remember I had this image previously of different blocks in a chain like this. And if you haven't figured it out already, what we're going to have in this is transaction data. So in this first block here, we're going to have some banking transaction. Here we're going to have some other transaction, and so on. And then on top of that, we're going to have multiple clients creating these transactions, and they might have blocks of different length like this. So this guy might have a longer chain, for example, like this. And we're gonna have a look at what happens when these two guys gonna start communicating with each other with different lengths of chains. Alright, so that is the basic gist of what this tutorial is going to be about. So I hope you guys liked it, and please stick around, and if there is any questions or uncertainties or comments, please leave it in the comment section below and I'll try to address it when I see it. So thank you guys for watching, and see you in the next tutorial.